Hello students, welcome to Unit 5 Notes, Section 7.2. I already did the warm-up, so feel free to pause the video at this time and complete it. And if you would like to, and now that we're continuing, I just wrote out my 3 congruent sides here. I just solved all 4 proportions. We're extending this idea of ratios and proportions to similar polygons. We're going to talk about similarity ratio. We are not going to, unfortunately, talk about the golden rectangle or golden ratio. Really, these are really cool things. You can definitely look them up on your own time on Google or Wikipedia. They are really cool ideas that expand on similarity, but we won't specifically be talking about them today. What we're going to do is work with similar polygons, identify if they're similar, but also apply similarity to them. So similarity, what is similarity? Well, it's when you have, unlike congruence, it's when you have 2 figures that kind of look the same, but one is larger than the other. So similarity, we use this symbol right here. This is our similar symbol. This is our similar symbol. You notice that's a symbol that we put on top of an equal sign. So let me write all 3 of these down. So that's similar. This is equal. This is congruent. Notice it's when we put the 2 of them together. So similar means, so equal means same sides, congruent sides. Similar means same angles. And together, when we piece them together, we have what's called congruent. So similarity is 2 shapes that have the same angle measures, but are not the same size. So we have 4 congruent angles in both of these, but unfortunately the sides are not the same length. But the sides are what we call proportional in similar figures. So 2 figures that have the same shape but not necessarily the same size are similar. 2 polygons are similar if 1, the corresponding angles are congruent, and 2, the corresponding sides are proportional. The ratio of the lengths of the corresponding sides is what we call the similarity ratio. So in this case, if f is 127, then we also know that b is 127 degrees. And if a is 53, we also know that e is 53 degrees. All right. And because of that, there's other conclusions, that we can make. But it says ABCD is similar to EFGH. So let's complete each statement. So measure of angle E is equal to 53 degrees. We definitely just answered that question. And I'm going to complete the second one, which is what was the measure of angle B? Well, that was 127 degrees. So we answered all of our angles now. But how are the sides proportional? Well, here they give us AB and EF. So we're going to say AB is to EF as what? As AD is to, well, it's going to have to be EH. And I can also pull it from this statement right here. So AB is in ratio with EF as AD is in ratio with EH. And so this EH, it's hard to see with that color. Let me try to change that. EH. All right, and the same thing here, GH and CD. So let's take a look at, notice I'm going from one shape to the other. You can't do similarity within the same shape. So you would never have GH is to FG as, whatever, no. So GH is to FG as CD is to BC. No, you got to go from shape to shape. So here GH is to CD as FG is to, it's going to have to be BC. So let's look, are they proportional? So GH is to CD as FG is to BC. Yep. We're going to stick with the order and it's all good. So determining similarity, we have to determine if these two things are similar. So here's how we start to do that. We're going to say that angle A is congruent to angle F. We're going to say angle B is congruent to angle E, and angle C is congruent to angle D. Notice it doesn't go in order. It goes A, B, C, D, E, F, kind of like this. A, B, C, D, E, F. That's fine. Don't force it. If angle A is congruent to angle F, that's fine. That's just what we need to write out. Now, we have this statement, so we know that the angles are congruent. So the next part is determining if the sides are proportional. So let's look at each one of these and try to go in order. Let's go with our smallest side, which is, well, let's go with the side opposite the 1 tick mark, so 12. Let's go with the side opposite the 1 tick mark, which is 16. And then let's see if that is proportional with what's opposite the 2, which is 18, and what's opposite the 2. Notice I'm going from top figure to bottom figure, back and forth, back and forth. So 18 to 24, and now let's go back to the top figure and look at 15 and compare that one to 20. And let's see if these are the same exact fraction ratios. So 4, 8, 12, 16. So this simplifies to 3 over 4. This one, 6, 12, 18, 24, simplifies to 3 over 4. And 5, 10, 15, 20 simplifies to 3 over 4. So guess what we just determined? We determined that all three sides are proportional and that all three angles are congruent. Okay, so that was one part. That was another part. And so we now know that these are similar. So when we go to write our triangle, the easiest way to do it is to pull right from here this information. So triangle ABC is similar. Notice I'm not using the congruent symbol. Similar to triangle FED. We've already determined the order. That's why I love writing it down right here, because I just went ABC, FED, and that's how I got my triangle similarity statement. So here's my triangle similarity statement. Oh, we're running out of room here. Let's move this up. Let's move statement down here. Okay, that's my triangle similarity statement. And now lastly, it wants the ratio. So we're going to say the similarity ratio. Similarity ratio is, we already did that work. It's right here. Similarity ratio is 3 to 4. Okay, so the triangle similarity statement we can pull from identifying what angles are congruent, and then from the ratio we can determine, actually writing the proportions, we can actually determine what the ratio is. So that was pretty cool. All right. So determine whether ratios are similar. If they are, it didn't say how to determine their similarity ratio. So sometimes we'll say small to large or large to small. I kept consistent with going from the smaller triangle ABC to the larger triangle FED. So I kept my similarity ratio similar like that. Now this one's asking us to sketch XYZ MNP and to so sketch XYZ and MNP, and let's see. Let me just sketch a triangle. I don't know what it's going to look like here. XYZ. And what I have the ability of doing, which is awesome, is just copying and pasting a larger one. I will change the letters though. Well, let's see, xy is 12, yz is 14, and zx. I'm going to have to rearrange my letters to make it a little bit more. Let's see, xy is the smallest, yz is 14. So I'm going to want to switch these, I'm thinking. Yeah, just to make it a little bit more relatable to the values that they gave me. They gave me 12, 14, and 16. That's all I'm trying to do here. So we have x, y, z, and we're going to do m, n, p. And for those values, x, y, z, so we have x, y is 12, 14, and 16. And mn is 18, 21, and 24. We know that x and m are congruent, so x and m are congruent. It says that y and n are congruent, and then z and p are congruent. And okay, can you conclude that the two triangles are similar? So we already have our angles, so that's awesome. I'm just going to rewrite that information. I'm going to say angle x, angle y, angle z is congruent to angle m, angle n, angle p. So we're going to check that box. And we're going to say we have to determine the side lengths. Ironically, they gave them to me in order, but we can still go, opposite 14, opposite 21. So 14 is to 21 as, as 24 is to 16. Whoa. As 24 is to, what is it? Yeah, I'm sorry. So I'm doing 14 to 21. So I'm starting with the top one, the smaller one. So 14 is to 21. So I have to go back, and 16 is to 24. So it's going to be smaller to larger again. And then it's going to be the last ones, which is small, which is 12 to 18. And we are just going to see if this all simplifies. So 7, 14, 21. So 7, 14, 21. So 2/3. 8, 16, 24, that's 2/3. 6, 12, 18, that's 2/3. So that checks out. Okay. And so, yeah, these are similar. And my explanation is what I wrote out here. I don't need to write any other explanation. This is plenty. So what I'm going to do, I am just going to write these things down. So the statement is x, y, z x, y, z, and m and p, and the similarity ratio is 2 to 3. And that looks good. Let's just be consistent with the colors, or inconsistent, I mean. Okay. So that one's good. So using similar figures. So knowing that they're similar, let's find the value of x. So we know that LM and QR are proportional. We know that MN and RS are proportional. We know that NO and ST are proportional. So we're looking at all of these to look for proportionality. See this 3.2? It's kind of not needed because there's nothing here to make it similar. But here are the similar items I can focus in on: 2 and X, and 5 and 6. And so I'm going to, again, you can't do 2 is to 5 as x is to 6. You can't set it up this way. You can't stay within your you can't stay within your figure. You have to go from figure to figure. So what I need to do is say 2 is to x, so left to right and left to right. So 5 is to 6. So I went left to right, and so when we do our cross products, we're going to get 5x equals 12. Oops, equals 12. Divide both sides by 5. We get x equals 12 fifths. Okay. Here's 12 fifths. So 12 fifths. It says find the value of x, which we did, and we are good. Now, what's the ratio? So this was solving for x. But what's the ratio of these? Well, the ratio, really, if I want to write it out, ratio is either from small to large is 5 to 6, or 6 to 5, depending on my order. Depending on order. That they ask me. Okay, so let's find SR, knowing that order happens, right? So we can use our 5 to 6. It says find SR. So I'm going to give this the variable y. I'm going to say, well, I can either use 2 is to 12 fifths as 3.2 is to y, or I can just do 5 is to 6 as 3.2 is to y, which I think I'm going to just use my easier method here. So I'm going to say 5 is to 6 as 3.2 is to y. Okay, and I'm going to do a triangle here and a triangle here. To show I'm comparing those items, maybe I should do that a little bit better. Oops. Huh. Oops. Paste. I'm just trying to show that those are the items I'm comparing. So 5 is to 6 and 3.2 is to y. And now that I have them, I'm going to do the cross products. So 5y equals, whoops, 6 times 3.2, so 18 and 19.2, I think. Let me just check it. 19.2, yes, so 5y equals 19.2. And so now I'm going to divide both sides by 5. So y is equal to 3.84, but it wants it to the nearest tenth. So y approximately equals 3.8. Just going to use the approximate symbol because I'm rounding it off. All right. Okay, so in this case, it wants us to find the measure of angle C and then write a proportion and solve it to find CP. So what I like about this is I like to kind of fill in all the information. So here they give me H, and what I know is W has to be the same thing. So I'm going to put in 80 degrees right there. And then they give me P, which is 38. So P is this one, so that has to be V. So that's also 38 right there. So now that I have 80 and 38 in both of my triangles, I can actually do 180, take away 80, which is 100, take away 38, which is going to be 62 degrees. So 62, so I get 62 degrees for N, but I also get 62 degrees for C, because N and C have to be the same thing. So 62 and 38 is, yep, 100, 180, good. So what's the measure of angle C? The measure of angle C equals 68 degrees. It doesn't like that box. Okay. So that's the measure of angle C. So now it wants me to write a, write a proportion and solve it to find CP. So I got to take a look at what they gave me they gave me WC, which is 10, and that correlates to HN, which is unknown. Okay, so I can't really use those values. So the value 10 is out, which means I'm going to have to use 14.5, which is WP, which is going to have to be HV. So those two are connected. So those two I can definitely use. And then notice that this CP is unknown, but I also know 12.8. So these are the values I need to work with. So these are compared to one another, and those are compared to one another. So I'm going to say 14.5. So I'm going to go from left to right. 14.5 is to 11.6 as x is to 12.8. And now I'm going to find my cross products. So I'm going to get 11.6x, and I'm going to generate this on the calculator. So 14.5 times 12.8 is 185.6. I'll divide both sides by 11.6. Okay, so divided by 11.6, and I get exactly 16. So x is 16. And so x is 16, but I don't want to write it that way. It says find CP. So I'm going to say CP equals 16. That's how I'm going to answer that question, not x. X is just a variable, but side length of CP is 16. All right. Here we got a couple more problems. Yep, we'll do all of these and then we'll stop at the notes and we'll do those in class. So use the figure at the right to find the measure of all of these items. So the first thing it wants to know, what is the measure of angle Q? Well, Q is similar to B. So B is 100, making Q 100. So the measure of angle Q is 100 degrees. And what is the similarity ratio from ABC to PQR? So that similarity ratio is going to be 14 to 20, and that's going to reduce to 7 to 10. We always want to reduce it, so it's a 7 to 10 ratio. Be careful, it's not a 10 to 7. It asked from A, this is the most important part, from triangle ABC to triangle PQR. You have to go in the right order. Okay, that's it for those two. So quadrilateral ABC is similar to quadrilateral JKLM with a similarity ratio of 2 to 3. So what I can do is I can write 2 to 3 as my similarity ratio. And so it knows that BC has a value of 8. So what is KL? Well, I can do, these are in 2 to 3, in a ratio of 2 to 3. So 2 is to 3 as 8 is to unknown, right? Because it's 2 is to 3 as BC is to KL. And so 2 is to 3. Here, let me write that right up here. So 2 is to 3 as BC is to KL. Therefore, I don't like this. Okay, 2 is to 3 as BC is to KL. And so therefore 2 is to 3 as 8 is to unknown. We're solving for KL. And we're going to do the cross products. So 2x equals 24. So x equals 12. So KL has to equal 12. All right. It says if BCD equals 38 degrees, so let's take a look at here. BCD, look at the order of BCD. It goes from BCD, and so find the measure of KLM. Well, that's an equivalent angle in terms of its congruence. So the measure of angle KLM has to be 38 degrees. So that was a pretty easy one based on that similarity statement that we were given. All right. You want to draw an enlargement of a design that is painted on a 3 by 5 inch card. You plan to draw it on an 8.5 inch by 11 inch piece of paper. What are the dimensions of the largest complete enlargement that you can draw? This one's a little bit difficult. Here's what happens. You have a 3.5 by 5, right? Let's say this is my 3.5 by 5 card. No, sorry, 3 by 5 card. We also have an 8.5 inch by 11 inch paper. Okay, does not want to do my paper for me. All right, let's say that that's the paper. The problem we're going to have is when we go to enlarge, let's say we take this. I'm going to change the color. Let's say when we take our 3 by 5 card and we go to enlarge it, right? What's going to happen is it's going to hit here first, or it might hit here first. So we won't be able to make a full enlargement. So what we got to do is we got to make sure we don't know how the proportion of this works. So I'm going to enlarge it until I hit a maximum or a maximum, and then I have to stop. So I need to run two separate tests for this. Again, I don't know, is it going here or is it going, whoops, is it going to hit here? It's kind of weird. Or is it going to hit here? And that test isn't too bad. You just have to, that's not what I want, okay? But the goal is that we enlarge it and we do it correctly where we don't overdo it because you can't print on something that's not printable, right? So I'm going to show you the strategy that will help you solve for this. So what we want to do is we want to test. So we're taking our 3.5 by 5 and we're testing it to make it as large as we can to be 8.5 by 11. So what I'm going to do is I'm going to ignore one of these values first and ignore the other value afterwards. So if I enlarge 3 to be 8.5, the question is, does 5 enlarge to be less than 11? If it's more than 11, it won't fit on this piece of paper. And vice versa, I'm going to increase 5 to be 11 and then see if my increase of 3 is less than 8.5. If it's too much, it's going to be too large. So set up two proportions, and you're going from smallest to largest because it wants you to maximize. It wants you to get your largest complete value. So we're going to do 3 is to 5 as 8.5 is to x. That's one of my tests. My other test I'm going to do is going to be 3 is to 5 as x is to 11. And again, if this is greater than 11, it's not going to work. We're going to ignore this one. If this is greater than 8.5, we're going to ignore that one. One of these will work where this will be less than 11 and this will be less than 8.5. So let's test both of these. So I'm going to do 3x. So 3x equals 5 times 8.5, which is 42.5. And I'm going to divide by 3, and I get, let me move all this up. Let me move that up. I get x approximately equals 14.16 repeated. Well, it's exactly 1/6 repeated. So I can change that to an equal sign because I have my little repeated sign. Okay, well, we know this can't happen. We can't have 14.16, so it would fail to exist here. So this is going to be my maximum amount that I can expand it. But let's do the math to find out what that is. So we get, we get 5 times x is 5x, and this ends up being 33. Okay, and so 33 divided by 5 is, x is 6.6. So this is the one that will work. And notice that 14.16 was too much for the 11-inch piece of paper. So it's 8.5 by 11. But this one, 6.6, is less than 8.5. So really, we're going to expand it as much as we can, which will be 6.6. So it says, what are the dimensions of the largest complete enlargement you can draw? So the largest enlargement will be, and we expanded it to be exactly 11 inches, but it's going to be 6.6 inches by 11 inches. And that's going to be our largest enlargement that we could do. This is a hard concept to understand, but I'm just testing both extremes to see which, if I do expand one of them to 11 or the other one to 8.5, which one would actually fit on that new sheet of paper. This next one is in reverse order. So a map has dimensions 8 inches by 15 inches. You want to reduce the map so that it will fit on a 4 by 6. So now you're shrinking it. So it's going to be the opposite way. All right. So we're going to compare, again, 4 and 6 are the maximums numbers that we can reach. So I'm going to compare, let's see, I'm going to use the same colors to, well, no, what did I use? 1, 2, 3, 4, 5 different colors. I'll use the same thing. So map has 9. So we're going to do 9 is to 15 as, what I do? 4 is to x. And that number cannot be greater than 6. Okay, if we get a number greater than 6, it won't work. And my other one is going to be 9 is to 15 as x is to 6. That one can't be greater than 4. So each one of these will test. We'll get 4 times 9, x times 9, and we get 60. In this case, we will find the cross product. So this one will get 15x, and we'll get 9 times 6 is 54. Okay, let's do divided by 9. We get x equals 60 over 9, which is 6.66 repeated exactly. Notice 6.6 is too large. 6.6 is too large, so it won't fit on this index card. Yeah, 9 will be shrunk to 4, but 15 will be shrunk to 6 2/3, and that doesn't work. It will fall off that index card. Take a look at this next one. 54 divided by 15 is 3.6. So divided by 15, we get 3.6 in the numerator. And what's good about that is 3.6 is small enough. So if we shrink 15 down to be 6, then 9 will shrink proportionally down to 3.6. It fits on this index card. So we're going to say the smallest, what are the dimensions? The largest possible complete map that you can fit on the index card. The largest possible map we can fit on an index card on the index card is, the largest possible map is 3.6 inches by 6 inches. And that's it. Again, a pretty difficult one, but I think, I think if you do a couple more of these, you would get the hang of it. All right, multiple choice. In our class is painting a rectangular mural for a community festival. The students planned the mural with the diagram that is 80 inches long and 60 inches high. The mural is actually 4 feet high. What is the length? So what I am going to do is I'm going to set this up. So we did what? Longest to high. So we're going to do long, so 80 inches long is to 16 inches high as we don't know how long, but it will be in feet, is to 4 feet high. And so again, I'm comparing inches to feet here, but as long as it's a proportion, it's okay. So I'm going to do 6. We know the answer will be in feet. So we're going to get 16x, and we're going to get 80 times 4 is 816, 320. So divide both by 16. X is equal to 20. It has to be 20 feet. So the answer is 20 feet. Again, can you convert to inches or feet? Yes, you can. But with proportions, as long as your items are, as long as it goes in the right order, 80 inches long to 16 inches high, mural long to mural high, inches to inches, feet to feet, it all works out. All right, money is our last example here. So from 1861 to 1928, the U.S. paper currency measured 7.42 inches by 3.13 inches. The dimensions of the current bill are shown here, which is 6.14 by 2.61 inches. Notice in 1928, we're talking Depression era. The economic depression that we had in the late 20s, early 30s. So maybe by shrinking the size of a $5 bill or a $10 bill, or all of our bills, if we shrunk the size of them, we'd probably save money on the printing costs. That might just be one of the reasons why we did it, or to restructure the dollar and give it a different approach. But to build some faith back into the system during the Great Depression or afterwards. So the dimensions of the current bill are shown here. Are the rectangles similar? So there's a couple ways to do this. We can, I think I'm just going to find the cross products of this and see if the cross products are equal. So that's one way of testing. So I'll do 7.42 is to 3.13 as 6.14 is to, oh, you know what? I shouldn't be setting up within each one. I'm sorry. So I'll do 7.42, which is length, is to 6.14. Again, it doesn't really matter for this, but I'll go from figure to figure and then figure to figure. So I'll do 3.13 is to 2.61. Now I'm going to find the cross products, and let's see what I get for a result. So 7.42 times 2.61, and we get 19.3662. The question is that equal to the cross product of this one? 6.14 times 3.13, and I get 19.2182. Okay, not exactly equal, but this is probably a rounded value. This is probably a rounded value. This is probably rounded. This is probably rounded. And this is off by, let's take away 19.3662. This is off by 0.148 inches. I think I would say that these are reasonably similar. I would definitely say that these are reasonably similar. Okay, again, rounding is going to take into effect. I think they shrunk the bill down exactly in proportion, and they had a similar rectangle. Okay, we'll start these in class. Good luck on your IXL.